Welcome to EOS Mathematics. Before we proceed, please subscribe and hit the bell icon to get notified of our upcoming videos. In today's topic, we are going to be talking about relationship between a sector and a cone. In the previous topic, we talked about circle, mensurations of a circle, and we talked about the length of an arc, sectors, segments, their areas, and their perimeters. Now today we want to see the relationship between a sector and a cone. First of all, we have to see how a sector forms a cone. Now we're going to draw the diagram of the sector. That's what we are drawing now. We have the radius of the sector. Okay, now we are going to try to bend the sector. So this is how it looks like when we bend it, and you find out that we are trying to form a cone. So a sector, when bent, ends up forming a cone. Now you have to notice something, that there are some similarities, or there is actually a similarity between a sector and a cone. From sectors we get cones. The radius of the sector is equal to the slant length of the cone. You saw where we are folding it. You saw the radius, where we held the radius and we bent it, and we saw that it is now equal to the slant length of the cone formed. Another thing we have to note is that the length of the arc of the sector is equal to the circumference of the base of the cone. Remember, the base of a cone is a circle. So we have that the length of the arc of the sector is equal to the circumference of the cone. Therefore, we can say that R, which is radius, is equal to L, which is the slant length of the cone, while the length of an arc, being theta over 360 times 2 pi r, is equal to 2 pi r, which is the circumference of the circle, being the base of the cone. Now we have a diagram here where we are representing a cone. We see that the base of the cone, which is a circle, also has a radius and has its slant length, and now has a height, because there is a height of the cone. Now if we are given questions that require us solving or trying to get the height of the cone, we make use of Pythagoras theorem, where L squared, being the hypotenuse, is equal to h squared, which is the side, plus r squared, which is the radius. Now peradventure we are told to find an angle. Remember that the angle at that particular point at the top of the cone is divided into two. So we divide the angle into two. So we have that since we might be given the length and the radius, we have that sine half of theta is equal to the radius being the opposite, all divided by the length. We now have that theta over 2, which is half of theta, is equal to sine inverse of the radius all over the length. Theta is therefore equal to 2 times sine inverse of the radius all over the length. Now we are going to see a question where a sector of a circle of radius 7.2 cm subtends at an angle of 300 degrees at the center and is used to form a cone. We are told to calculate the base radius of the cone formed and the vertical angle of the cone. First of all, we draw our sector showing the radius 7.2 cm and the angle 300 degrees. Now we are going to fold our sector to give us a cone. Remember that the radius of the sector is equal to the slant length of the cone. So here we have that the radius is equal to L. Therefore, we have that L is equal to 7.2 centimeters. Now, we are going to also represent the radius of the cone. But we remember that from what we learned in the previous slide, that the length of the arc of the sector is equal to the circumference of the base of the cone. Therefore, we are going to try to equate that. So we have theta over 360 times 2 pi r is equal to 2 pi r. Remember, the 2 pi r on the right hand side is that of the cone. Now let's bring in the fractions of the angles on the length of the arc of the sector to the left. So we have 300 degrees all over 360 times 2 times pi times 7.2, which is the radius of the sector. It's equal to 2 pi, and we don't know the radius, so we are going to make the radius of the cone base our subject. We have 2 pi cancelling out 2 pi, and we are left with 300 times 7.2 all divided by 360 as being equal to r. If you're following with your calculator, you could punch that out. 300 times 72 will give us 2160 divided by 360, which gives us that r. Remember, we're told to find the base radius of the cone formed. We have that 2160 divided by 360 is equal to, or will give us, 6 cm. So r is equal to 6 cm. Now we know our r and we know our length. The next is for us to find the vertical angle of the cone. Remember, since we know the slant length and the radius, we can be able to find half of the vertical angle of the cone, and that will make use using our trig functions, where we have that sine of an angle is equal to opposite all over the hypotenuse. Now we have theta over 2, which is half of the vertical angle of the cone, being equal to 6, which is the opposite, all divided by 7.2. So 6 divided by 7.2, we remember 6 is our opposite and 7.2 is our hypotenuse. 6 divided by 7.2 leaves us with 0.8333. Now we are going to look for the theta divided by 2, which is half of theta, and half of theta is equal to sine inverse of 0.833. Sine inverse of 0.833 will leave us, or will give us, the answer that theta over 2 is now equal to approximately 56 degrees. So leaves us with an answer that theta over 2, which is half of theta, is approximately 56 degrees. Now, for us to find the vertical angle theta, it will be equal to 2 times 56, and 2 times 56 will give us 112 degrees as our answer, approximately. Other questions, you could be told to find the height of the cone, where you will have to make use of the formula which we saw in the previous slide, where we used Pythagoras theorem to find the height. If you like this video, please hit the like button and share with your friends. See you next time.